Alright guys, for this video we're actually going to take a look at notes that we did probably way back in the second marking period. We did do finding limits, which is really the start of calculus, so we kind of really already have a head start on it. And I'm just going to go over it again so you can just take the notes off of this. You can see I already have the definition down, and in fact you did take this definition down before, but if you haven't or you don't remember, please take this down right now, all 4 of these boxes that I have outlined in black. So with limits, so again, what this means is, to just explain it before we do the examples, whenever you take a limit, what this means is where it says X and you have an arrow and has the C plus, when you find a limit, you're going to get the Y value on the graph. And if it has the plus, that means it's the graph of f of x approaches from the right of C. So that's where you have a plus. If you have this C and this minus, then you're approaching from the left of C. Alright, and basically what happens is, if you find those two limits as you go from the left of a number and then to the right of it, if they converge to the same number, meaning that if these are equal to each other, the y value as it approaches from the right, and here the y value as it approaches from the left, then we can say that that limit at that number, where we don't put a plus or minus, equals whatever that number is. If these do not equal each other, then we say then the limit doesn't exist. So if you move it around, I don't know if it cuts it off right there. See, we have this DNA or DNE. So if these limits don't equal each other, then the overall limit does not exist. All right, pretty simple concept. We'll take a look at a couple examples, but I think once you see it, it'll come back to you, and it's very, very simple. So if I look at this graph, I kind of have a funky looking graph, and we have taken a look at a lot of graphs that have holes or they have asymptotes. If we look at this first row, okay, kind of zoom in a little bit. So if I do this first one and say, all right, what is the limit of this graph, f of x, as x gets closer to 2, and it says from the left, because I have a minus. So here is where x equals 2. And then from the left, it means I just follow this graph from the left, and you can see from the left, this is what it approaches. Now it says, what does the y value approach, not what does the y equal, because there's actually a hole right here. This is what it approaches, so it's -1, right? This is the y value here, -1. So that's the answer for this one, -1. And then the next one says, all right, what's the limit as x gets closer to 2, but you're approaching it from the right of 2? So if I just follow this graph from the right, it's the same thing, right? It approaches, goes all the way down here at this y equals -1. So you get the same value. And then since these are the same, since these equal each other, then we can say as x approaches 2, it's the same thing, it's -1. Now the other last thing I have in here, it says find the function of 2. We do this because it kind of shows you a discrepancy amongst finding limits of certain x values and finding the y value when you plug an x in. Sometimes there's a discrepancy, and there is in this case. If we actually find the function of 2, it's actually this point. Since there's a hole here, this y value, it's the limit, but it's not what the y value equals. This is what the y value equals, which is y equals 1. So you get a different answer for that. Okay, let's move to, let's just do the next row. Okay, if I do the next row, we have saying what is the limit as x approaches 3, but it's a minus, so it's from the left. So from the left of 3, right, here's 3 right here. From the left, if you look up, this goes all the way up, and 3 is where you have this asymptote. This goes all the way up to infinity. So the y value approaches infinity as it gets closer to this 3 from the left. So we're going to put infinity here. Now we do the next one and saying, all right, what's the limit as x approaches 3 from the right? So I go to the right, here's 3. Now when I go to the right and I follow it, now this does the opposite. It goes all the way down to -infinity. So that's the limit. Now here's the main thing. Since these are different, right, since they're different limits from the left of 3 and to the right of 3, then when there's no plus or minus, then we can say the overall limit does not exist. They approach two different values. And then the last thing, if I want to find the function of 3, well, here's 3 right here. Since you have this VA, this also doesn't exist. There's no point on the graph where x equals 3. So we'll put does not exist. All right, and that's kind of it. It's real basic. It's very, very similar to what we did earlier in the year. The only last thing I'm going to put in here, and you can take this down in your notes, the tricky cases where you have to figure out if the limits are the same or if they're different is if you get these, which are holes, or you get this, which you have asymptotes. So I'm going to write down very last thing, and I think we did talk about this a little bit in the second marking period. I'm going to put holes and asymptotes. Those are called points of discontinuity. So I'll just put, I'll just write discontinuities. This is going to be a term that you see all the time in calculus. So basically we say a graph is continuous if it's a smooth curve and it continues. But if you have any gaps or jumps, we say those are discontinuities. And these are examples right here, any holes or asymptotes. All right, so what you guys can do is just finish the rest. Everything on the packet, all the pages front and back, and then we'll go over this the next day on Tuesday.